Thanks for coming. Zuhair was describing it very well that I had a lot of pain over the last 2 months. So just to give you a little where this topic comes from is we've shipped a major update of our iPhone and Android app and changed basically everything, how Keepsake works under the hood. The user doesn't see a difference, but everything changed. And we changed the way we store stuff and all kinds of things. By the way, are people shy? First row? Shyness? And so I've more or less worked on, after the first release, for 2 months to ship one fix after the other with really unexpected things that I never thought would be possible. And so now here, 2 months later, 17 updates later, we rolled it out to all our users and feel quite comfortable. So this, for everyone, for the people who don't know what KeepSafe is, we develop personal privacy products in a bigger scheme. And our most popular and first application is an app where you can store personal photos behind a pin in a private photo gallery that is not accessible without a pin, and it takes the photos out of your normal photo gallery. So when you hand your phone over to other people or whoever, you don't have to be afraid that people see something that they shouldn't see. So that's what we do. This is how it looks when you open the app. So let's get in. Oop, here we are. And so when I thought about the problems we're having and how my software development life was before that, I define it as there are certain things that you kind of rely on, right? And the best thing I could come up with is what everyone knows is when we walk around on this earth, there's gravity, right? So I can jump up and I know I will land again. And it's it's pretty certain that this will happen anytime I jump up, no matter what I do. And this is the set of rules I'm moving around. And so I had the same perception about certain things on mobile development, but it turned out that there's a different world out there that is a little further away, and you don't really get to it just by accident. Where gravity is suddenly not as you expect it to be anymore. And so what I want to do today is I just want to run you through some issues we came along and what we did about them and how that changed our thinking and building apps. Everything is around the topic of when you store data on the device for your users, and it's data that is sensible and that you have to rely on, that it's there and that it's correct, right? It's not about, you have a app where you do some image caching, and if your images are corrupt, then you just download them again. It's about data that is not replaceable, and where the app stops functioning, or you can just not get it back. So when we started out, you think okay, what can happen? So we ran into some interesting exceptions. I think it's a little hard to tell in the back, but I'm just gonna read it out loud so everyone knows what it is. So we started to see funny exceptions like a file not found exception for a certain file name with the error message permission denied, which is interesting because it's a file that I've been writing over and over again since the lifetime of the users, and suddenly I want to change it and I get a permission denied, right? It's okay, that's interesting. So another one is KeepSafe lives in a folder on the external storage is what Android calls it. It's if you have an SD card, it's your SD card. Otherwise, it's the storage that other apps can access. It's flash storage. And it's the same folder. We have read and write permissions from the OS, and we use it over and over again. But every now and then we get an I/O exception with read-only file system. I'm wasn't read-only just a little while ago, so now it's read-only. What happens? Another one is out of quota, failed, quota exceeded. I still haven't figured out exactly what quota I've exceeded. because I check if there's enough space on disk, but suddenly I don't have quota anymore. So maybe we have to like upload or upgrade our quota. But all those things are still fine because it's an exception. You can catch it and you're like, something didn't really work. I just try it again or whatever, right? But then it's like, this is like, no problem. We can deal with that. But then there's like things where it gets a little different, where like you stored something, but it's not really stored. So if you look at this, it's hard to read. So it's like just a few lines of code. So basically, it's a method that gets a file, a destination file, and gets an input stream. And we open an output stream, and we write basically with a buffered output stream. We write the data to disk. And at the end of it, when the stream is empty, the input stream is empty, we flush the output stream, which basically just like empties the output stream. Then something that's very important that I'm not sure if everyone does, but it's highly recommended. And on Android, you have to do this. You have to get from your file output stream, you have to get the file descriptor, and then you have to call sync on it. Because if you don't call sync on your file descriptor, it's actually not guaranteed that the data is written to disk. But after that, it should be guaranteed, or it is guaranteed, according to documentation, that your data is fully written to disk and the file system is in sync. So then I close the file, I close the file output stream, and that all runs through, and I don't get an exception because I would throw an exception. So that worked, and we ran into issues where suddenly we couldn't read certain files, and we couldn't figure out why. So then we just started to add a bunch of more code. That's like, programmers do that. So whatever you see here is basically an extension of the previous method. Those slides will be online if you want to look it up later in more detail. So what we basically started doing is, while we write out the initial input stream, we compute an MD5 hash of the data that ran through my method that I'm writing out. And what we then do afterwards is we started to compare the length, and we count the bytes that we write. We started to compare the length of the bytes that we just wrote, and then we looked at and compared the length of the byte that the file has that we wrote. And I run into cases where the file does not have all the bytes that I just wrote. I counted them, right? I just went through my loop, I counted all the bytes that I wrote, and then I look at the file length, and they're not written. And so we're like, that's off. And then you look up documentation. It says, file.getLength returns the length of the content of the file. Some people thought it's different. So we actually double-checked. And when the length of the file is different than the length of the data that we just wrote out, we thought, OK, let's compute an MD5 hash of the file that we just wrote to disk. Right? And so there's a method here that basically does that. And then we compare those two MD5 hashes from the one that we just computed while writing, and then the MD5 hash that we computed after we wrote the file without getting any exceptions or error messages. And if they're not the same, we basically throw our own implementation of a giant what the fuck exception. Right? There's a message that says, like, after fsync, the file length is not equal to the number of bytes we wrote. This one. File length is not equal to the number of bytes we wrote. We expected, in this case, so this is an exception I catch from our crash logs. We expected it to be notice this, like 2,575,953 bytes, but actually it's only 2,553,857 bytes. Ooh, that's like, where did they go, right? And then the file hash is also different. So that was the moment when we were like, holy fuck, this is like, we cannot rely on that. This is actually doing what it's supposed to do, even if it says it's doing the right thing, right? If you move on. We have similar things in iOS as well. Like this is iOS code. Basically, it's like it's a file input stream, it's a file output stream. After we wrote it, we also compare the file size if it's the size of the written file is the same as what we expected. And we also run into issues that this is not always the case. Right? And that becomes very critical if you store things like users' encryption keys on disk and other things like that. So what to do with it, right? What we did in the example was where we compute the MD5 hashes. We basically return, besides throwing an exception, we return if the file is actually the same one that we expected. So we have a return value when we write a file to disk that tells us if it was successful. The other thing that Arthur gave us an advice early on is like, if you write files to disk, don't overwrite an existing file with your new content, because you never know if it works to write the new content to disk, and if it breaks while writing to disk, you lost your previous content. So you basically end up in a state of nothing. And in cases when you want to update a file, that's nothing is pretty bad, right? So what we do is we have a little method that's called transaction-safe file util. And what it basically does is if we have a file that we want to change, we write out the new version of the file in the file name .new. If that is successful, we then change the original file name to file name .old. And if that is successful, we then rename the file name .new name to file. And if this is successful, we delete .old. And so with this method, whenever one of those operations breaks, because we also had problems where rename didn't work, whenever one of those operations break, you always know you still have the previous or the new version that is correct. And that, in combination with actually checking that the stuff you wanted to write to disk is actually on disk, has served us very well. It's a little overhead, I have to say, but it works. Other things that we discovered is just because it doesn't work the first time doesn't mean it doesn't work the second time, right? It's like let's just try it again. It's like, oh, try again works, right? So every now and then in our code base you'll find stuff like retry count and save success, and then it's like just while retry count is small as 3 and save was not successful, just do this, right? In this particular example, we are trying to store a string into the shared preferences of the Android OS, and the commit method that basically writes it out to disk synchronously returns false, and even with that we still get a few cases where this doesn't work. It's still false. So retry is one of the strategies we started implementing. Another one is, what do you do if it doesn't work even after retry, right? What we end up doing is, if it's sensitive, like if I have a new app installation and I have to store the user's encryption key and I cannot store it, I'll just crash the app hard. It's just like I just throw a runtime exception and say like, sorry, no more for you. Before, or better said, instead of letting the user into a state of the app where it's not usable or you have the risk of losing data, right? So the other thing, what we also do is when we expect certain input to be at a certain length, right? So here's an example where input should be 32 bytes. And even if in the entire code base, the only place where we write the data to disk and read it again is in one place, and I never write anything else in 32 bytes. We ran into issues where it's suddenly not 32 bytes for whatever reason. So whenever we take input, we always make sure it's the right length, in this case, for example, right? Because sometimes it's not, and I rather crash the app than having a wrong input that hurts the user's data. what are our learnings from this, right? So we thought a lot of this stuff is like you just follow documentation and it works. We realized it's a lot more dirty than what you think it is. And by now, I think we're at the point with the entire team where we don't get surprised anymore by exceptions that are random, right? So I have examples where I have a file and I say, if is file, then this, if is directory, then this, else, what else can it be, right? And I catch that. Or I get from the Android operating system, I say get caching directory from the context, and I get a directory back. It's not null, it does exist, and then somewhere it says like is not directory. All kinds of things. I rename files, and suddenly I can't read them anymore. So we are in the mindset of like, we expect everything. We're also in the mindset of don't touch data that you've written to disk if you can avoid it, right? And I really mean that by like even basic things like, yeah, just rename this entire folder and then I move it back. There's always the chance that you cannot move it back for whatever reason, or the data inside might not be available after anymore. So really we're like, once we have it written on disk, we try to avoid anything to actually modify existing data. And then the other thing is we just get super paranoid about where data is sensitive to actually make sure it's 100% the right data and it's written to disk, and we just verify it before we do anything. And some of the stuff here in the presentation we implemented in our core methods where that's just required, so if you call it as a developer you don't have to worry about it. But yeah, that has been our biggest learnings. It's quite a surprise from where I come from. I did a lot of like graph visualization and stuff before, so you don't have to worry about things not being the right way. But that's what we learned, and I just hope it helps everyone here to avoid those problems, or at least be aware of those things. And if you get to the point where you want to store sensitive things that you have to rely on, you're like, I've heard something, I might double check what it is. The other thing is just have really good crash analytics. That gets you a long way of figuring out those problems, because none of those problems that I've described have we ever reproduced on a device here in the office. Not a single one. It's all out in the wild, and then you just guess your way through what could it be. So yeah, thanks so much for coming.